Okay, and this is our last booklet of the year. So just like the last one, the algebra and functions, this is a booklet we're going to start the year 12s with next year. So this will be their second booklet after algebra and functions. So most of this stuff you'll know, but it's just, again, recapping it and maybe formalising it and tightening up on a few things and linking it to the functions work we've just done. Now, there's going to be a section that we talk about concave, convex, without actually knowing how to differentiate. Oh, well, the year 12s won't know. So let me know what you think about that. Okay, so we're going to start off with, first of all, we know all our theory about mappings and functions. So we're going to, first of all, look at how we can draw graphs for them, because that's all a graph really is. A graph is just a mapping put on a set of axes. So we can use graphs to draw mappings of the form y equals mx. And in order to draw that, we put the x, the input, on the x-axis, and we put the output of the mapping on the y-axis. Should say mapping there, not function. And for every input, we do the output. So, for example, that's what you get. These little dots mean that they're not the output. So, for example, it goes all the way up to that point, but not that point. So think of the inequality like x is less than 2. You would draw a number line and have a circle of 2. That's all it means. It's not that point. It's every point up to that point, just not that point. Yes, and then we have a straight line, we have a circle, we have a few random dots, and we have a curve like that. So by looking at the graphs, we can tell which ones are one-to-one, many-to-one, one-to-many, and many-to-many. So if you can see if you can spot them yourself just by looking at them. Well, this one, if you can see, it's one point goes to one point. However, if I look at these points here, then many points go to that point. So this one will be many to one. This one here, again, if I look at the point here, there's 2 points that go to that point. So it could be many to one. Then also, if I look at the point here, this input gives 2 outputs. So in fact, this one's many to many. This one here, well, if I pick any input, I only get 1 output. And if I pick any output, I only get 1 input. So this one's 1-to-1. This one, if I pick an input, I can have 2 outputs. And if I pick in an output, I could have 2 inputs. So this one's many to many. This one here, if I pick an input, I only get at most 1 output, look. And if I pick any output, I get just 1 input. This one's 1-to-1. And this one again, if I pick any input, I get 1 output. If I pick any output, I get 1 input. So this one's 1-to-1 as well. Okay, so we know that 1-to-1 or many-to-one is a function. So these 4 things here are functions, or could be graphs of functions. These 2 can't be functions. So we can test, first of all, if a graph is a function by quickest ways, and you kind of saw me doing it. It's something called the vertical line test. So that just means if I draw a vertical line, it'll cross the graph at the most 1 point. So look, if I draw any vertical line, it'll only cross the graph once. So therefore, it's a function. Yeah, whereas if I did it here, look, if I drew a vertical line there, there'll be 2 places it crosses. So it's not a function. Here, if I draw a vertical line there, there'll be 2 places to cross. So again, it's not a function. And just a few more examples at the bottom. So this is a function. This one's not. And this one's not. Okay, the next thing is we like to know functions have inverses. And if you can remember from that first booklet, functions have inverses if they're 1-to-1. So we need a test to see if they're 1-to-1. And the easiest test is something called the horizontal line test. So if I draw a horizontal line and it crosses the graph once, and it has an inverse. Yeah, more than once doesn't have an inverse. So if we look back on our original 6, this one was a function, but look, if I draw a line, a horizontal line here, it crosses 1, 2, 3. So it's not 1 to 1, so it doesn't have an inverse. What is this one? Anyway, I draw it across once, same here, and same here. So if you're testing a graph to see if it's a function, you do vertical, and to see if the function has an inverse, you do horizontal. Okay, so see if you can have a go at working out what type of mapping these 6 graphs represent, and decide if it can be a function, and if it's a function, say if it can have an inverse. Okay, so this one here, well, if I draw a new line, crosses once, and the line here crosses once, so it's 1 to 1. So that means yes, it's a function, and yes, it has an inverse. This one, again, any vertical line crosses once, any horizontal line crosses once, so yes, it's a function, yes, it's got an inverse, and it's a 1 to 1. This one, my vertical line, look, crosses twice, so it's not a function. So therefore, it's not a function, it doesn't have an inverse. And if you think about it, that's 1 going to many. Yeah, now try picking an output. There's an output, there's only 1 input. Output, again, only 1 input. Output, only 1 input. So it's 1 to many. Again, remember 1 to many on the function. So remember, if it ends in 1, it's a function. So 1 to 1 or many to 1 is a function. The other 2 are not. This one here, well, crosses twice. So it's not a function. So it doesn't have an inverse. And the type is, well, we've already talked about that one in the first page. It's many to many. This one, if we draw my vertical lines, they only cross once. So yes, it's a function. If I draw a horizontal line though, it crosses twice. So no, it doesn't have an inverse. So that means it is many to 1. So if I pick an output, look, so these two are the same output, they're the same height on the y-axis. There's 2 inputs that give that output. So it's many inputs to 1 output. And this one, yes, it's a function. No, it doesn't have an inverse. And it's many to 1 for the same reason as the other one. Okay, the next thing we can talk about is coordinates can really be seen as inputs and outputs of functions. Now, if you can get your head around this, it will help the whole of functions and graphs completely. So, for example, if a coordinate 3, 5 lies in the graph of a function y equals f of x, then that tells us that f of 3 equals 5. That if I input 3, I output 5. Because remember, we put input on the x-axis and output on the y. So f of 3 equals 5. So you're just going to have to go converting between them. See if you can do some yourself. So f of 4 is 2, f of 0 is 1, f of 1 is 0. So I know that if I input -1, the output's 7. So -1, 7. If I input 1, the output's 7. Oh, sorry, -7. If I input 2, the output's 9. I've got the inverse though. The inverse, when I put 2 into the inverse, I get 9. So that means when I put 9 into the original, I get 2. Because I can remember, I can use that rule to the function on both sides. So they cancel. So I get 2 equals f of 9. So 9, 2 is my coordinate. I get here a, b. Here I get a is my input. B plus 1 is my output. Here, a plus 1 is my input, b plus 1 is my output. Here, if I input 2a, I get 5a as an output. If I input a squared, I get b plus 2 as an output. Okay, next one. So here's a sketch of a function, and it's a piecewise function, so it's split into two parts. Use the graph to find out g of 2. So if I input 2, so put 2 on the x-axis, the output, well, it's 0. If I input 8, my output's 4. Okay, the inverse of minus 9, so that means my output is minus 9, so what's the input? Minus 9 is my output, the input must be minus 1. The inverse is 2, so that means the output is 2. What's the input? So 2's here. So what gives me 2? Well, it's in the middle here, so it must be in the middle of these two, so it must be 5. And g of 2, well, we know that g of 2 was 0. Then if I input 0, I get minus 6. What's the domain of g? Well, the domain of g is a set of numbers, and the domain number is the input, so it goes from minus 1 to 8. And the range is the output, so the range g goes from minus 9 to 4. Okay, I'm going to leave this example and come back to it because I think I've rejigged the booklet. And I think I'm going to stop the first video there.